So we're going to talk about volume of prisms and cylinders. And first of all, we're going to use our green paper to find the equation for the volume of a prism. And if we look at our green paper, what it says is it says that the volume equals big B times H. Big B means area of the base. And at the top of your green paper, there's a key. It's got little b, big B, lowercase h, lowercase r, the different symbols. And again, the big B means area of the base. The volume of a cylinder, again, if we look right underneath the general prism formula, the volume of a cylinder is not so generic. It's pi times r squared times h. And what we're doing here, the reason that it's not quite so generic is that what does a cylinder look like? And if we flip over to, or flip down to our first example, this one is the cylinder. And over here to the right, this is actually a rectangular prism. Or actually it could even be considered a square prism. But in all cylinders, the base is a circle, and the formula for the area of a circle is pi times r squared. That's why in this particular formula, it's pi r squared h. And on the prism, again, it's going to be the area of the base. So we need to look at the base. In this case, our base is this. And once we know those two things, then we can apply our formulas to them. And you might want a calculator or you might want Desmos. But it says for a cylindrical drinking glass and a square prism drinking glass of the same dimensions, which would you rather have? So we're going to start by figuring out, well, what's the volume of a cylinder? And the first thing to notice in this particular problem is that we're given this length. And that length here is the diameter of the circle. But we don't need the diameter. That's not in our formula. We need the radius. And the radius is half of the diameter. The height of this particular cylinder, we're looking at the left-hand figure, is 12. And once we know that information, then we can fill in our formula and calculate. We're using our calculator or using Desmos. So the volume is going to be pi times the radius squared times 12. And it doesn't say to leave the answer in terms of pi, so we're going to multiply everything here, and I need to write this again. Pi times the radius squared times the height. Now that we have that a little bit better. So we're going to pull out our calculator, pull out Desmos, whichever works. Desmos is actually easier with pi, but on the calculator it's second and the caret button, there's the pi, times the radius, which is 3 squared, times the height, which is 12, and here we get our value. And I don't know if I put the rounding in or not. It doesn't say round, but I'll round to the nearest hundredth. So our volume is going to be 339.29. And volume, by the way, is measured in cubic units. So this is inches. Cubic means to the third power. And you probably have some experience with the volume of cylinder and volume of prism, at least I hope you do. But once again, the formula for the volume of the prism is area of the base. And I have the area of the base, or I have the base highlighted over there. And what we have is we have the same side length here. So the volume is actually going to be base times height, 6 times 6 times 12. rectangular prisms, the square prisms, length times width times height is maybe what you learned in your earlier math classes. But once again, what we want to do after we figure out the area of the base, by the way, here's the area of the base. There's the big B. And then the 12 is the height. So we type that in, and we've got 6 times 6 times 12, which gives us this dimension here. Scan it in a little bit better. And when we fill that in, what we've got is we've got 432. Again, volume is cubic inches. And then finally, the question is, for a cylindrical drinking glass and a square prism drinking glass of the same dimensions, which would you rather have? Well, if you're wanting a lot to drink, then what you want is you want the prism glass. So what's going to be important on these is going to be, can you identify the base? Can you identify the height? And then knowing the formulas, but the green paper will be provided for you. So you don't have to memorize a formula. So if we look at the next example here, it says find the volume of each object. And what we need to be able to identify is this a prism or is this a cylinder? And the cylinder always has a circle in it. Do we have a circle anywhere in this? We don't. So this is going to be a prism. And in fact, if we get even more specific here, it's going to be a triangular prism. And what happens with the triangular prism is the formula we're using is the area of the base times the height. But we need to go back and we have to remember, and not really, but we have to remember what the formula for a triangle is, finding the area of the triangle. And again, if you look on that green paper, it just so happens that the formula for the triangle is in there. So in this case, the area, the big B, the area of the base, is going to be 1/2 times base times height. And on my picture, you can see it, it's shaded here, and it looks like I cut off a value. No, I didn't. But what we've got here, so the thing about this is, this length here is 17, which means that this length here is also 17. And we need that information because the base, the big B, is going to be this shaded portion of our prism. And what we need to figure out is, well, what is the length of that side there? Because we eventually are going to have to figure out the area of the triangle, and then we're going to have to multiply it by the height. So when we do that, that's going to require us to go back and use the Pythagorean theorem yet again. So it's going to be 8 squared plus 8 squared equals 17 squared. Type it into Desmos, type it into your calculator, but 8 squared is 64 and 17 squared is 289. If we subtract 64 from both sides, we end up with a squared equals 225. And we want to find the square root of that. And the square root of 225 is 15. Again, just because I'm doing it doesn't mean that you can't or don't need to use Desmos or your calculator. So what we know now is that this value here is 15. And we can find the area of the triangle. Because the formula of the area of the triangle is 1/2 times the 15 that we just found times the 8, which is already in the triangle. Remember here, even though my picture's a little bit off, but that's a right angle there. So when we type that value in, 0.5, which I use for 1/2, times 15, times 8, gives us 60. So big B here, I took it and I broke it apart. Big B is 60. And maybe you need to do it separately, maybe you don't. But once we know that, we're going to take that value and we're going to put it back into our volume formula. And this is going to be 60. And the height of our figure is 13. And then when we figure out the volume, 60 times 13 gives us 780. Again, our cubic inches. Letter B. This one's called an oblique cylinder because it kind of leans. But what we have to do, the nice thing is it's identified for us that this one is going to be a cylinder. So we already know the formula we're going to use, which is going to be the pi r squared times h. And then what we're going to do is we're going to fill it in. Well, our pi, our radius, it's given to us in this particular cylinder. We've got, it's kind of that pinkish color right there. That distance is 4, so this is 4 squared. And then the height of this figure is outside of the cylinder, but again it's listed as 9. And let's type that in. By the way, sometimes what this says is, sometimes it says to leave the answer in terms of pi, so I am going to write it like that. And pi has given some people trouble when using the calculator. It's easier to use on Desmos, but if we type 4 squared times 9, that gives us the 144 pi. But we don't have any directions that specifically say that, so I do want to type it in as a decimal. And again, if you're using the calculator, we're going to take 144 times second, and then the caret button will get the pi button, and that gives us 432.389. I'm going to round to the nearest hundredth, so I'm looking at the 9 to determine what to do the 8. Because 9 is 5 or higher, we're going to round that up, and we end up with 452.39. And again, cubic units for volume. Letter C. Again, the two types that we're talking about today are prisms, or cylinders. The fact that we don't have a circle in this one means that, once again, we're dealing with a prism. And the formula for a prism on our paper, it says general form, big B times H, area of the base. And we need to identify the base. And if you prefer, what you see in terms of the base, again, it's kind of shaded on mine, but we see that it's a triangle. And once we know that, the formula for the area of the base, and I did it separately on the first one, now I can do it together here. Area of the base is 1/2 times little b times h. The base of the triangle that's highlighted there or outlined, and then times the height. So this is the big B formula, and then our height. Well, what we know in this formula then is it's going to be 1/2. The base of the triangle, just of the base of the base, is 12. The height of that given triangle is 8. And then the entire height of this prism is 20. and we can type that into our calculator to get our result here. And it is, I'm going to use 0.5 times 12 times 8 times, and sorry, I got extra parentheses in there, but it's okay, times 20. I'll close it there. I didn't really need the parentheses, but actually I can go back and do it the way that we had it on our paper. Times 20. There we go. I think that's right. And enter. And that gives us our value here, which is that our volume is 960 centimeters cubed. And as we go throughout this unit, the important fact is going to be, can you identify what figure you're working with? So we're going to start, and we've kind of broken it up into pieces, and then as we move along in the unit, then we're going to mix them all together, and we have to be able to identify the different figures. But again, the formula paper will be provided for you. Switching it up just a little bit here, but still doing the same kind of idea here. It says find the height of the figure with a given volume. So once again, what we know is that we have a triangle for a base. We don't have any circle in this problem, which means that we are going to be working with a prism. And the area of the base, or the general formula, is big B times H. And ultimately what we want to do is we want to figure out, well, what does that H in that formula right there stand for? Because we know what the volume is. The volume is given to us, it's 27. And our big B is going to be determined by finding the area of the triangle, which also happens to be a formula on your paper. So this is going to be 1/2 base times height. And then again, what we're trying to find is the height of the entire figure. But we're given enough information here. We need to be really careful when we look over here. But the height of this triangle is 3, and we have a tick mark in it. But if you look closely down here at the base, there's another tick mark in that triangle, which means that this length is also 3. And we have at least 2 congruent sides, which means it's an isosceles triangle. And now we have everything that we need, because it's going to be 27 equals 1/2 times 3 times 3, and then we want to figure out our height. And if we type in 1/2 times 3 times 3, then we're going to get 4.5 times H. 0.5, I can type it in. 0.5 times 3 times 3 gives us 4.5. That's where the 4.5 came from. And then lastly, what we want to do to figure out the height of this figure is we want to divide, because it's 4.5 times H, so we have to undo that multiplication by dividing by 4.5. And 27 divided by 4.5 gives us 6. So our height